Alright, let's begin. So for this video, we're going to be talking about the message queues. So for the client side, the message queue is handled at the start of the game loop. For the servers, I have it processed after the local player 2 inputs are received. Excuse me. So for the message queue, there are three different types for the messages that they could be. They could either be normal mode, recording mode, or playback mode. So on the client side with normal mode, it starts off with processing incoming messages. So when we process incoming messages, we receive the messages from the server, which involves getting a packet from the factory, deserializing the packet, which means getting a packet from the header, deserializing the header, and then grabbing the proper packet from packet message based on what type it is. So grabbing it from the factory and then deserializing it and deserializing the stamp and frame. Once we have all of that, then we can pass that into our input queue. So we loop through that until we have all of it. For processing the input queue, we end up executing all of the messages, and if any message is supposed to be received both ways, then we will resend the message by initializing the header with the same data type, same reliability, and same channel, but we update the destination from being both to server. After that, we add it to the output queue, which for adding to the output queue, we then send messages to the server, so we just serialize the packet, which will then be serializing the packet header, and then serializing each individual packet message. And then we send that message. Sending the message is just taking the method and channel, both of which you grab from the header, or reliability and channel, and then you send it to the server. So that's the normal gameplay. For the recording mode of it, it's the same exact process, except every time you execute a message, you are writing to a file. So we have a file stream here with a designated path. We're writing to our file every time we execute, which will also include the timestamp. So the timestamp is whatever the current time of the game is when it's executed. Once we have all of that, nothing changes in the output because we only care about when messages were executed. When we go to playback mode now, we will read from that file we sent in the recording, and then we will use the timestamps to determine when we execute the messages. So if the timestamp is less than the current game time, then we will be executing it. So long as another message exists within our file, we will deserialize the next one, and then we will just keep doing this while the current packet's timestamp is less than the current time. If we are at the end of the stream, then we set this flag to true, and that will prevent us from going into this while loop anymore. And then we'll just say it's the end of the recording. For the serialization, deserialization, we'll do that really quickly. So here's the serialize, deserialize for the collision, message, fire message, the header I already showed, mine message, move message, network we already know, the position message. This is the Dead Reckoning variant that has velocity and time associated with it as well. The time reply message, and the time request message. If I were to quickly pop over to, is this one Dead Reckoning? It is not Dead Reckoning. This is the position message for the player prediction one. This one is what the Dead Reckoning message is, except without the velocity or the time attached to it. Since we are here also, I will segue on over to this. So for the server side, for player prediction, it involves processing the incoming messages, which is exactly what happens with clients, where we get the packets from the factory, deserialize them, add them to the input queue. Once we do that, we process all of our input queue, loop through, execute. If we find anything with the destination of both, send it to the client, and then add to the output queue. There are two extra steps for the server, which is sending the game state. Sending the game state for the player prediction involves getting the position for both of these ships, as well as every missile in the game, or currently active in the game, and getting all their positions, sending it to the message queue, to the output. Once we send it to the output, we then add the collisions to the output queue. So to try and keep everything organized for me, I have the contact manager adding these collisions to a separate queue, the collision queue. This collision queue is just there to make sure that all of the missiles and mines are created before any collisions occur. So so all missiles, mines, and collisions are handled with the same reliability and same channel. So that way that all the missiles and mines are handled, then all of the collisions are handled. Um, Once we have that, then we finally process the output queue, which then involves sending the messages to the client, which is the same thing as what the client does when sending to the server, write to the stream, set it to the array, get the reliability, get the channel, send the message, you're good to go, and then recycle the packet. Um, the recording mode is very similar to the normal mode, and how the client side only changes it by adding flushing stuff. So every time we execute, we flush to the stream. Sending the game state, we add stuff to the output queue, and then we out for the output queue, we send it all still. Where's that? Right over, right over here. So we end up sending everything still as we usually do. And then for playback, we don't send anything. We just read specifically from the file. For the Dead Reckoning server, um, yeah, Dead Reckoning. Pretty much everything. It does everything the same as what the player prediction strategy is of processing incoming, process input, send game state, process collision, and then process output. The main difference here is because for Dead Reckoning, the players are predicting missiles. We only need to send the position for the ships, and we send this position solely if the server's prediction of the client is ever beyond our threshold. So we have this boolean here for when we predict our position. If the predicted position we find is beyond our thresholds, we set the deviation variable to true. And back to over here, when this returns true, that is when we pass in all the necessary data and then update the data for the server's prediction data to match. Um, so that's the normal one. There's also the recording one, which once again, same exact thing of flushing everything to the stream whenever we have it. Once again, ignoring the missiles because we do not need them for the Dead Reckoning. And then the playback mode is just reading from the file until we reach the end of the file. And that's it.